Just finished eating a sandwich. I'm Skip Alsheimer. Welcome to the AV Geeks Lunchtime Streaming Show. Sorry. That's gross. Anyways, we watch old 16mm films. And today, I have a advisory council meeting with Apple Shop, the archive that had flooding back in the summer. So we're going to go with some longer films today so I can kind of listen to this advisory meeting and we can talk about how we can help out all these materials that were flooded. But yeah, so let's go ahead and start off with this first film, which is narrated by someone you might know. So it's on the scanner behind me. So let's go ahead and watch Universe. Enjoy.
The study of the universe spans almost inconceivable extremes of size and distance and time. From the vast island of stars we call a galaxy to the tiny atom and the particles that comprise it. From cosmic events that occurred billions of years in the past to microcosmic events in the present that endure for only billionths of a second. To explore the universe at these extremes, the scientist builds instruments that extend his reach and his vision. His great telescopic eye has the light-gathering power of 1,000,000 human eyes. It peers not only into the depths of space, but far back in time, since the light it now observes may have left its source when dinosaurs inhabited the Earth. His telescopic ear is tuned to the invisible radio sky. It detects not objects, but the radio regions associated with them, and at distances far beyond the range of the largest optical telescope. But the radio waves and the visible light that pass through the Earth's atmosphere to these ground-based telescopes are only part of a broad spectrum of radiation, most of which is blocked by the atmosphere. So electronic instruments are lifted above this murky and turbulent layer. Airborne by rockets, by balloons, in unmanned astronomical observatories, in manned laboratories, and in spacecraft orbiting the planets. Instruments probe the near and distant environments of space and open new windows on the universe. In the beginning, it is believed, all the matter of the universe was contained in a primordial atom, an unimaginable concentration of elementary particles. In one gigantic detonation, the contents of this cosmic fireball were hurled outward in all directions. After 1,000,000 years of expansion, the universe was an intense blaze of light. Then the radiation cooled. And after hundreds of millions of years, great clouds of hydrogen gas began contracting. And it evolved into the galaxies we now observe. Inside these galactic whirlpools, smaller fields of gravity condense hydrogen into stars. Stars are inconceivably hot. So hot, they sustain thermonuclear reactions that transform hydrogen into heavier elements. Sometimes their hydrogen fuel burns so fast, they flare out in violent explosions, hurling new elements across space. Like a great wind, the radiant energy of starlight drives these clouds of dust and gas throughout the galaxy. Out of these clouds evolve new generations of stars. More than half the stars in our galaxy travel in groups of 2 or more, orbiting around a common center of gravity. Like galactic comets, immense clusters of stars swing in and out of the galaxy in vast, eccentric paths. Some small stars do not travel in the company of other stars. Our own sun is one of these. To the astronomer, the sun is a vast laboratory for the detailed study of a star's structure and energy. The vertical tower of the solar observatory supports a heliostat mirror which tracks the sun, gathers its rays, and reflects them down a light shaft that extends 300 feet below ground. At the end of the shaft, the rays are cast back to an observing room where minute-by-minute changes across the face of the sun are observed. Another mirror projects a light beam to a spectroscope, an instrument which splits the light into its component colors, a visible spectrum. The dark lines that cut across the spectrum band are produced by the radiation from the sun's interior shining through its atmosphere. Each line is the signature of a chemical element such as sodium, iron, calcium. It is this array of lines that forms the code which describes the properties and motion of a star. By narrowing the view of the sun to a single line of the spectrum, each level of the solar atmosphere can be photographed, and each reveals a remarkably different aspect. And with the addition of computer mapping and color processing that distinguishes levels of brightness, a detailed and multidimensional picture is obtained of a sun undergoing dramatic and turbulent change. The sun is a sphere of hot, seething gases and surges of radiation. Most of the light we get from the sun comes from the thin, bright layer which defines its visible edge, the photosphere. Above it, the chromosphere, a region of flaming outbursts of gas, extends through a transition zone to the thin outer atmosphere of the corona. Once thought to be a quiet layer of the solar atmosphere, the corona is now revealed to be a region of dramatic large-scale changes and unexpected turbulence, with temperatures reaching millions of degrees. Deep beneath the sun's atmospheric shell is the core, a violent nuclear furnace. Here, hydrogen is fused into helium, and in the process, some of the matter is converted into an enormous amount of energy. Radiating outward as a gas, it convects like a boiling liquid beneath the surface. The turbulent, bubbling motion is visible in the granular cells of the photosphere. Sunspots, regions of intense magnetic fields, appear on the surface, disappear in a few hours, or grow and persist for months in a mysterious 11-year cycle. The sun rotates once in 27 days. Because its equatorial regions rotate faster than the polar caps, the shearing action in the gas contorts the magnetic field into tangled structures which give rise to the sun's eruptive action. Shaped by these magnetic fields are the spectacular prominences, titanic streamers of gas reaching heights of more than 500,000 miles above the surface. The greatest explosions in the solar system are flares, intense bursts of light erupting with the force of billions of hydrogen bombs. They move at hundreds of miles a second. Then, after minutes or hours, they fade away. The dark areas across the solar disk are coronal holes, which may provide new clues to the sun's interior, and may be a source of the solar wind that blows outward to the farthest planets. On Earth, effects of these solar events are visible when auroras light up the dark Arctic sky and radio communication is disrupted. The sun is an average, middle-aged star. Yet it will generate heat and light for billions of years to come, as it has for 5 billion years past. It dominates the motions of all bodies in the solar system. Nearest the sun and obscured by its intense glare is Mercury, a cratered planet much like our moon. Temperatures rise to 800 degrees, but no clouds or atmosphere protect its ancient surface from the searing heat. Moving outward from Mercury, we encounter Venus. Its perpetual cloud cover traps the radiant energy of the sun within an atmosphere of incredible pressures. From the surface, only a reddish glow reveals the presence of the sun. Beyond Venus, 93 million miles from the sun, is Earth. Its great oceans forming the clouds and air currents which warm and irrigate the planet, shape its continents, and nourish life. Its satellite, the moon, airless, waterless, and scarred by meteors that have bombarded it since the time of its formation, now bears the imprints of our astronauts. A probe of the planet Mars has discovered a dynamic and evolving planet with unexpected geological features. A volcanic mountain, many times larger than the largest volcano on Earth. A vast and deep canyon extending for 2,500 miles. And dry, river-like channels that may have been carved by running water. Beyond the orbit of Mars is the belt of asteroids, craggy chunks of rock and metal, some as small as boulders, others hundreds of miles in diameter. About 500 million miles from the sun, we encounter the first of the giant gas planets, Jupiter, the colossus of the solar system. more massive than all the other planets combined. Deep beneath the maelstrom of clouds that band its surface is a primordial atmosphere much like that in which life awakened on Earth millions of years ago. And drifting on its surface is the mysterious red spot, an immense cyclonic storm that has raged for hundreds of years, continues unabated. Radiating more energy than it receives from the sun, and circled by 14 moons, Jupiter is like a miniature solar system. The next largest of the gas planets is Saturn, girded by rings which, as we approach them, resolve into countless particles of frozen debris and ice, each a tiny moon orbiting the massive planet. And as we continue past the frozen worlds of Uranus and Neptune, we arrive at the outermost planet in the solar system, Pluto. It moves in a dim twilight of unimaginable cold. The sun, 4 billion miles away, is only a brilliant light in the night sky. To travel beyond the solar system to the nearest star would require a journey of more than 5 trillion miles. Yet our sun is only one of 100 billion stars, widely separated from one another in time and space, but all bound by gravity, and all revolving around the central core of our galaxy, the Milky Way. Drifting between the stars are vast clouds of gas and dust, the nebulae, made luminous by the radiation of stars within or near them, or darkly obscuring the light of whatever lies behind them. Here, new stars are being born. About a half-century ago, our galaxy was thought to be alone in the universe. We now know it to be one of a local group of about 20 galaxies. And strewn through the vast reaches of space are more than 10 billion galaxies, grouped in clusters as far as our most sensitive instruments can reach. Little is known about the evolution of galaxies, and why some are formless or irregular, others elliptical, and still others spiral-shaped. And we know as little about the galactic core and its role in the galaxy's evolution and structure. The problem has become more perplexing by the discovery that some galaxies are in a state of extreme disarray, exploding, ejecting gaseous matter, or interacting with other galaxies. Even more puzzling are quasars, star-like objects, emitting as much energy every second as the sun radiates in some 10 million years. They appear to be among the most remote objects in space. Stars are born, live out their lifespans, and die. The life history of a star is marked by an opposition of two kinds of pressure. One is the pressure created by the energy in the core of the star, pushing the surface outward. The other is the crushing force of gravity pulling the star's surface inward. When these are balanced, a star becomes stable and shines steadily. As hydrogen fuel is depleted, the release of energy is insufficient to withstand the gravitational pressure, and the core collapses. But compression by gravity raises the temperature in the core, and helium ash rekindles the nuclear fires. Vast amounts of energy are released and lift the outer zones against the force of gravity. The star is now a red giant. In the final stage of its evolution, it is the mass of a star that determines its fate. The Sun, a medium-sized star, remains stable for approximately 10 billion years. Then it will expand to 400 times its present diameter. As it expands, it will engulf the inner planets, Mercury, Venus, Earth, and Mars, and create a nebula extending past the outer planets. After millions of years, its reserves of nuclear fuel will be exhausted, its outer layers will have dissipated, and only a white dwarf star remains, no larger than the Earth. Slowly cooling to 0 temperature, will end its life as a black stellar corpse. When a star more massive than the Sun reaches the red giant stage, the collapse of its core raises its temperature billions of degrees and triggers a spectacular detonation. A supernova explosion. At the center of the explosion, a residue of the star is crushed by gravity to a neutron core, only a few miles across, but so dense that 10 billion tons of its matter would fill only a tablespoon. It spins rapidly, generating radio signals in its strong magnetic field. And a radiation beam sweeping past the Earth is observed as a pulse. The star is known as a pulsar. An even stranger end is predicted for very massive stars. According to the laws of gravity as presently understood, nothing can stop its collapse. The star disappears from our universe, leaving a black hole in space. Its presence can be deduced only by its influence on a visible companion star, distorted out of shape by the black hole's gravitational attraction. Gas, pulled off the visible star, circulates about the black hole, and in the dizzying plunge, it emits X-rays which can be detected in space. No light or matter can ever leave the intense gravitational field of this cosmic abyss. The physical laws that govern the conditions within this bizarre object are totally unknown to us. The evolving universe itself must come to an end. If it continues to expand indefinitely, the light of every star will in time be extinguished, and the galaxies will disappear into infinite darkness. But if gravity halts the expansion, the universe will fall back on itself. Galaxies will lose their separate identities. Stars will explode, and the sky will again be ablaze with light. Finally, all matter engulfed in a fireball like that from which it emerged. All things on Earth, living and inert, are formed from the elements forged in some distant and unknown star. On Earth, atoms joined together in definite numbers and patterns compose the organic molecules which form living cells. Since the discovery of complex molecules in the chill vacuum of interstellar space, there is reason to believe that among the countless galaxies in the universe, there are stars orbited by planets favorable for the evolution of intelligent life. Is space travel to these planets possible? time and distance may be insurmountable barriers. The spacecraft Pioneer, now speeding toward the outer planets and beyond, traveling at 35,000 miles an hour, would take almost 80,000 years to reach the nearest star, Alpha Centauri. A spacecraft traveling 2,500 times faster than Pioneer, at 10% the speed of light, would require so great an expenditure of energy that until new sources have been tapped, it must remain an invention of science fiction. A more practical strategy in the search for extraterrestrial life is to tune in on radio signals traveling at the speed of light, beamed perhaps by creatures on the planet of some distant star. Someday, an array of telescopes, earthbound or lifted to the far side of the moon, may hear faint but unmistakably meaningful sounds amidst the din of cosmic radio chatter. That moment will signal a change in the human condition that we cannot foresee or imagine. For man, wrote H.G. Wells, there is no rest and no ending. He must go on, conquest beyond conquest. And when he has conquered all the deeps of space and all the mysteries of time, still he will be beginning.
Everybody's comments about William Shatner, the man, the myth, the narrator of a universe. This is a great film, I think, because it's almost all animated. It's using some photos and some artist renderings, but it's definitely a trippy film. Like, you could probably show this after everybody drops hits of acid. So I'm still on a conference call, and coincidentally, people were starting to ask me questions, and I said, wait a minute, I have to intro the next film before I can answer your questions. So this is the next step. It's about water. Enjoy.
th century American farm. Cleared by pioneers, generation by generation. This is achievement. Under widely varied climatic and soil conditions, progress is constantly generation adding its own step in the process of building up toward a greater tomorrow. A goal somewhere on ahead. That's the way you build. Step by step, in a nation or on a single farm. You start with the soil, add a few buildings. Gradually, you build from there. Like Wayne Dickinson, farmer, and Esther, his wife, both born on farms, lived on farms all their lives. Now they have a place of their own. The former owners let it run down. But the Dickinsons have started again the step-by-step building up. Already they envision their goal. They see their farm not as the rundown property it is, but as it when the building up is done. Their farm tomorrow. Better buildings, soil enriched by conservation, upgraded livestock, better machinery, running water where it's needed, a profitable place to work, a healthful place to live. But all that will come a step at a time, with good planning, sound management, hard. And right now, it is hard work, lacking some of the facilities that make work easier, make more work possible, make building up faster. Even keeping clean is hard work. Pump and carry, that hard work can earn the equipment that in turn means more profit, more progress. If they're fortunate, young farmers have the help of experienced old-timers, like the Dickinson's man, Pappy, who has worked this place 40 years, won't leave it, practically came with the deed. Hard-working, ever-loyal hands, like Pappy, are a priceless work power on any farm. Nature thrives under their care, and their greatest satisfaction is to see growth, although it's right in their judgment.
Time it takes to heat that water for the dishes. Ah, well, just wait till we get our plumbing in.
Plumbing? What's this about plumbing?
Yes, Pappy. The next step we take in building up this place is going to be running water all through the farm.
Carry your water, I say. That way you know where it is and how much is there. We carried every pail of it on this farm for 40 years.
No, Pappy, our minds are made up.
But if you just got to spend that money, why, a new building for them little pigs, now that would be something else again.
Oh, you'll get a house for your precious hogs, Pappy. That's in the plans, too. But now we're going to have water. It'll make all kinds of difference around the barn and yard. Certainly make Esther's work easier. And then, too, it's time we thought a little more about health and sanitation around here. For the kids' sake, if not for our own.
We were just wondering, Pappy, if you knew the best plumber in town. We haven't been around here long enough to...
Plumber? Plumber, you say? Why, doggone it, boy, what am I around here for? Can't I lay pipe? You gonna let me sit around here and do nothing?
No, Pappy, there'll be work for you, don't worry. But we've had experience with running water. Both our dads had it, keeping it in tip-top shape afterwards. But who's going to be the plumber? That's the only problem now.
Many a farmer's problems are answered through his mailbox, his traditional contact with industries built to serve him.
Hi, what's in the mail?
Look, Wayne, this may be the answer to what we were wondering about last night.
Oh, it could be. Well, let's see him the next time we're in town. At least ask us to visit him. Can I help you folks? Well, I don't know. We just dropped in because we got your circular on farm water systems.
Circular? Oh, you must mean my Home Desirable, a little magazine I mail out. Have I met you before?
No, our name is Dickinson. We took over the old Fowler place.
Yes, I know. Well, I'm glad to meet you. I'm John Rourke.
How do you do?
I know your place pretty well. By there a couple of weeks ago. So I happened to put your name on my mailing list. By golly, you've certainly done a lot to it in the short time you've been there.
To be done, though.
Well, you're never finished on a farm, are you? But you've got good land to start with, the main thing.
We're the place we've been looking for.
You milking many cows out there now?
27 now, feeding a few steers, too.
Well, I sure wish you luck. That farm's been sort of an eyesore to this district for years. We were all pretty happy when we heard a couple of young folks had come to take it over. If ever I can be of any help to you, well, I'm always here.
Well, I don't know. We're just wondering about running water on the place. Don't know whether to bother with it or not.
Well, you'll have to be the judge of that. I've installed good many systems around here, and I don't remember any of the farmers wishing they had their old windmills back again.
No, I guess not. Don't know whether we can afford it, though.
Well, that depends on what you need, seeing what kind of an installation you want.
Oh, I don't want very much. Line into the barn, a couple of plumbing fixtures around the house. Just a simple job.
I'll tell you what I'll do. I've got to go out to Norm Hancock's, just beyond you there. How'd it be if I stop on the way back, and if you've got an idea of what you want, I'll look the place over and come pretty close to telling you what it'll cost.
Well, oh, I don't know. All right, then. No harm in finding out. You know where the place is?
Oh, yes, I know the place. I'll see you tomorrow, then. Well, thanks for coming in.
From that minute on, the Dickinsons had another partner in planning the future of their farm. Wayne's water problems became John Rourke's problems. How they worked them out together is a story being repeated daily throughout America as farmers take the next step in building up. Let's hear Rourke's own version of this one.
The next day, I went out to the Dickinson place. He'd certainly made an improvement. Some new machinery. Barn was tidier than I'd ever seen it. Generally, the place was starting to look worked again. He had a few water problems, all right. In the first place, the old well was too close to the barn. It wasn't healthy. And him with 2 little children, too. There was a much better location for a well, up by the house, on much higher ground, and far enough away from the barn to prevent contamination. The capacity of the old well wasn't enough for Wayne's water needs either. So, first we'd have to drill a new and bigger well. Like any good farmer, Wayne's first interest was his stock. He really had a water problem there. He'd been using a pump jack to get water across to the tank, and sometimes it took until 11 in the morning to get... Wayne already knew that individual drinking cups would give him at least an extra can of milk a month, and the first thing he asked for was individual cups at every stall. Time saver, money maker. This boy Wayne was proving to be a pretty smart farmer. Wayne's next interest was the milk house. His dairy reports clearly indicated the need for a better water supply. He had a makeshift line from his well to a cooling tank. Actually, Wayne needed cold water running through the tank a little faster, and a line to his hot water tank for sterilization. I had to consider Wayne's long-range plans, too, make allowances for his future needs. For example, a new hog house that he planned to build near the barn later on, and an increased chicken flock. At that time, Wayne only had about 250 chickens, not really enough to justify an automatic drinking fountain. But he expected to increase his flock as soon as he and Esther got time to look after them. Well, I was pretty sure Esther would have that time as soon as she got water in the house, so I planned a line to the chicken house to save carrying the water. Well, that was it for the barn and farm buildings. All I had to do was pace the length of the water distribution lines needed. There was an ideal location for the septic tank and drainage beds near the house, on the side opposite the new well. Next, I had to consider the house. Esther had a pretty good idea of what she wanted. A well-laid-out kitchen where she could work quickly and efficiently. That kitchen was a real problem, all cut up with doors and windows in the most inconvenient places. But Esther knew what she wanted. How to get it for her was my problem. We could get a 60-inch sink under this window. A nice, pleasant location, too. But the window was too low. We'd have to raise it up about 4 inches. Then we could put in a good work surface right over to the corner. We could move the range, but that still didn't give us room for the refrigerator. We'd have to move the rear door the sink was. That would give us a good, workable plan with the refrigerator next to the door. Well, that was it. We'd do a little remodeling and give Esther a first-class kitchen. There was only one location for the bathroom, off the bedroom in a large closet. We'd cut a new door from the hall. There'd be plenty of room for the water closet and lavatory. Since the room was just 5 feet wide, a fully recessed 5-foot tub could be installed with minimum work. Of course, the window would be over the tub, which we didn't like too well, but it was a pretty good solution for an old house. In the basement, I advised Esther against laundry tubs until she could have a utility room upstairs. The new well would be right outside that wall. So I'd put the pump in the corner and the tank and water heater alongside with hot and cold water faucets and a hose to fill the washing machine. I had a real drainage problem. 2 small children make for a lot of washing. We'd need a new drain to take care of that. Well, that ended my survey, and I made a date to meet the Dickinsons at my store the following week to see the plans and fixtures.
Hello, Mr. Dickinson. Ms. Dickinson. Oh, how do you do? Well, that was nice timing. I just finished getting the data together for you. Now, here's what I planned according to our conversation the other day. This is the general layout. Your new well will be here, near the house, and big enough to give you plenty of water. Pump and pressure tank are in the basement. Then we'll run this supply line out from the house. Here, we'll put a faucet for fire protection. Now, these lines supply the drinking cups, and this one runs to the present drinking tank for the steers. Then we'll run a branch line to the milk house. Now notice, I've indicated provision for another branch line, so when you build your new hog house out here, we can get water to it without much trouble. I've included a line to the hydrant at the chicken house, and I'll provide a connection for a future branch line in case you want to extend it at any time. And here's the location of the septic tank and disposal field.
Looks pretty good. Ought to save a lot of work for both of us.
What about my kitchen? What's it going to look like?
Well, there it is. You remember, we moved this door so we could install a more efficient kitchen. Here's the refrigerator, the stove, and here's plenty of working surface and cabinet space. The sink will be over here under the new window. And here's the bath, with an entrance from your bedroom, also the hall. You see, you have plenty of space for a big closet. In the basement, as you remember, we were planning on installing a hot water heater in addition to the pump.
Well, it sure makes a nice layout. Don't know that we can afford it, though. How much is it going to cost?
Well, there's the estimate, everything included.
Mr. Rourke, can you answer the phone? It's Mr. Hancock.
Will you pardon me a moment? You two look over the estimate while I'm gone.
Look, there it is. Why, his price is less than we figured we'd have to allow.
Shh, not so loud. It looks good so far, but I just hope he included everything we talked about the other day. Let's see. Does this include everything, Mr. Rourke? All the labor, materials, installation, and fixtures?
Yes, everything. That's the job complete.
Can we see the fixtures you plan on installing?
Sure. I have them here on display. Now, of course, you're not limited to these items. I picked what I thought you'd like as a basis for my estimate, but I want you to look over my complete line and choose whatever suits you best. First, here are the 3 bathroom fixtures I figured on. They're beautifully styled, built to last. This tub is made of long-lasting, rigid cast iron with a good, thick, shiniest glass. This lavatory, or wash basin, is vitreous china. As easy to clean as your dishes. Look at these faucet handles. They're beautiful and so easy to operate. The closet is vitreous china, too. Easy to clean, easy to keep clean. Its cleansing action is vigorous. I know you'd appreciate these bathroom fixtures, Mrs. Dickinson.
They are beautiful, Mr. Rourke. But what about the others you mentioned? Tubs, for instance.
There are 3 kinds of tubs. This one of cast iron, others of an earthenware material called Duraclay, others of pressed steel. Each has its features. All are good. Here's a Duraclay tub you may want to consider.
I think I like that one the best. The one you included in your proposal. That wide seat will be convenient when bathing the children.
Now, there are other lavatories I want you to see. They're all high quality. One will last just as long as the other. It's all a matter of style. Take this one, for instance.
I think I like that one best. It matches the other 2 pieces so well. Well, that's fine for the bathroom. Now, what about the kitchen?
Here's the sink. A sunny day with under-sink cabinet. Of course, you're going to have extra cabinets, both wall and base. The sunny day sink makes housework easier. The double drain boards afford lots of room and are pitched to drain into the sink basin. This sink is really very easy to keep clean, and I'll show you why. The sink and the drain boards are made all in one piece. One smooth surface from here right across to here. There are no joints or crevices around here to catch dirt or moisture.
This will be fine. It's beautiful, Wayne. Well, that takes care of my department. I'm satisfied.
What about the pump, Mr. Rourke?
Well, there are 3 of the types generally used. For your job, considering the probable depth of your new well and the amount of water you'll need, I recommend this jet pump. It has only a few working parts. That minimizes maintenance requirements. And I know it'll give you all the water you need.
Well, you know more about that than I do, so I'll take your word for it. And I'll hold you to it, too.
All right. Come over here. This is the heater I included in the price. I handle heaters that use coal, oil, gas, and electricity. If I remember, you expressed a preference for an electric heater. You'll find this one economical to operate, and it'll keep hot water at your faucets 24 hours a day.
I'll take your word for that, too, Mr. Rourke. Well, that looks like all the fixtures. Hey, not yet, honey. We can't get everything right now.
Someday, though. And it's worth waiting for.
Yes. And one of these days, we'll be putting in one of these modern heating systems, too. But what about our present job? Are you completely satisfied with it, Esther?
Oh, yes. I'm very satisfied.
Well, I think we'll go ahead with it, Mr. Rourke. How soon can you start?
We'll be finishing at the Hancock farm next week. I'll start at your place the following Monday. We started right on schedule. One of my mechanics and I laid out the location of the underground water supply pipe, and he started digging the trenches. We've used this machine for a couple of years now. It digs a trench faster, better,
and at lower cost than hand labor. As the trenches were dug, a plumber mechanic laid the water pipe. A frost-proof hydrant installed near the chicken house completed the outside water piping job. Next, we laid out the location of the disposal system so waste could be safely taken care of. Here again, our trench digging machine came in handy. On this job, we used a steel septic tank. Sometimes we use concrete tanks. All depends on conditions. For the entire disposal system beyond the septic tank, we used fiber pipe. It's easily laid and roots can't cause trouble. To backfill the trenches, we again used mechanical methods. They're time savers and money savers. I told my well driller to use a steel casing large enough to ensure a sufficient volume. And a few days later, we struck plenty of good, clean water. Then we ran a pipe through the basement wall and connected up the new pump. We installed faucets in the milk house and another faucet in the barn. The drinking cups were put in, and after the water was turned on, the valves were adjusted for per volume. Building the bathroom required quite a bit of preliminary work. First, we marked where the fixtures were to go. Then plaster and lath were removed. Holes for the waste outlets were cut through the floor, and we were ready for the actual installation. Each fixture had to be vented to the outside air so sewer gas couldn't back up into the house. This meant a hole through the ceiling, one through the roof, for the main vent pipe. Making joints with lead and oakum for some of the waste lines, and cutting and threading steel pipe for others looks easy. Actually, it takes years of experience. Installing a bathroom calls for a lot of piping, waste pipes and vent pipes, lines to bring in hot and cold water. We know a piping system must serve for many years. It's going to be plastered in permanently. So it was just good sense to use the best material available. Proper functioning of the plumbing system is impossible without correctly installed concealed piping. Before the room could be plastered, the bathtub had to be set in place and leveled to ensure correct drainage. We cut a new door from the hall into the bathroom, giving access from the rest of the house. Remodeling in the kitchen began with the removal of the old sink, probably a marvel in Grandma's day. Things have sure changed. Then the old hand pump came out. To me, that relic was a symbol. The Dickinsons had parted with the past. We're taking a big step toward better living. The carpenter cut a new rear entrance to the kitchen. Afterwards, he closed up the old one. He removed the window in order to replace it with one that would fit over the new sink. Like the bathroom fixtures, the sink had to have hot and cold water piping, a waste line, and a vent line. The plasterer added his know-how. Then the prefabricated cabinets were installed, carefully leveled, and firmly anchored to the wall. The undersink cabinet was leveled too. Esther's kitchen already looked more modern. Vital operating parts of the faucets were assembled, and the completed sink was placed in the leveled cabinets. The factory-made countertop fitted perfectly, and the kitchen installation was complete. After the kitchen was done, work in the bathroom went right along. The closet bowl was set in place and fastened to the floor. Then the closet tank was installed and bolted firmly to the bowl. We hung the lavatory and connected it to the wall piping. When that was done, the bathroom fixtures were all ready for service. With the redecoration of the bathroom and kitchen, our work was done.
Yes, Rourke's work was done, for the time being anyhow. Eventually, there's always more to do. We call that progress. Rourke and his men had done a fine job, and the Dickinsons were a happy young couple. They had stars in their eyes that day, especially Esther. Everybody drank a toast to running water. And you know, before the glasses were half empty, they were already talking about that utility room for Esther. How it would have a convenient place for the men to clean up and leave work clothes near the outside door. An adequate supply of softened water for every need. And of course, modern... But all that would come later, in due time. Yes, they drank a toast to water and a better future. The Dickinsons never realized how much running water would mean until they worked with it for a while. No more pump and carry. Simply turn it on and use it. And when you're through with it, down the drain. What could be more convenient? A day at work or play. Cleaning up was a real pleasure, no longer a task. Among other things, running water saved Esther enough time to get those extra 200 chicks and look after them. Wayne was a much more efficient farmer with running water wherever he needed it. His cows gave more milk than he anticipated. A full extra can the first week after the new installation was finished. His milk was grading better because he had plenty of hot water for sterilizing and cold water for quick cooling. Everything was so much easier to keep clean. Even Pappy was won over. His protests gave way to pleasure and progress. And this wasn't the end, just another beginning. The step-by-step building up, what we call achievement and progress, never ends. Those who build and grow, like the Dickinsons, never stop. They only pause long enough to see how far they've come, where they're going. Then they start planning step.
Hello, everybody. I'm invisible. Thanks for tuning in today. That was a fascinating film. I like films that kind of talk about new advances in infrastructure and things that we take for granted now. And yeah, so this was pretty great. Plus, it was beautiful color footage. Holy cow. So we'll be back again tomorrow, Wednesday. I'm still testing negative, but I'm beginning to feel like I might be getting sick, but I don't know. So if I'm sick, we'll still do a show, but we'll just see how I'm feeling day to day. But I gotta say, if I had worn a mask during the whole conference, it would not have been a problem. So join us tomorrow. If you like what you saw, you can buy some coffee at ko-fi.com, or you can go to patreon.com/avgeeks. You can also hit the thumbs up and the like button. Those are all wonderful ways to say thank you. And I say thank you to you. So we will see you tomorrow. Everybody have a good Tuesday, as good of a Tuesday as you can possibly have. We will talk to you soon.